Bismillahirrahmanirrahim. My dear students, Assalamu alaikum. This is our lecture number 25 for this subject of operations management. Today, students, we will discuss a very important topic, that is forecasting, and that is the process of actually predicting our future. As an operation manager or as a general manager, you may face the different situations in which it is so necessary that you have to forecast for the future. For example, what can be the your expected demand for your products in future. Similarly, what can be the human resource requirement for your particular organizational requirements. So these are the situations in which this process may play a very important role, which we usually refer as forecasting. But before discussing forecasting, let's have a recap what we discussed in our previous lecture. Students, in our last lecture we discussed again some important cases for the assignment problems, and previously we discussed the different assignment models in which we were interested either in the minimization of cost or the maximization of profit. And you know what different steps we follow in these particular methods. We generally follow different steps of Hungarian method, and you already know that what the different steps are involved when we are interested in maximization. That is, we'll have to find out some maximum number, and we can subtract all the values of the matrix from this maximum number so that we can have a new matrix. And again, we will follow these same steps as we follow in the minimization problems. And similarly, we can have another method for this maximization problems. That is, we can change the signs of all the values of the original matrix, and then again we follow the different steps of minimization assignment problems. In the last particular lecture, we discussed some unbalanced problems related to the assignment models, and we discussed that there may be the cases when there may be more number of jobs, or maybe the cases when there are more number of machines. So we discussed actually two important cases, that is when the number of jobs are more than the number of machines, then what we decided that we'll have to add some dummy jobs or the fictitious jobs, or we'll have to add the dummy machines if the number of machines are less than the number of jobs. So after introducing these dummy machines or dummy jobs, we'll have to allocate the cost equal to 0 for these dummy jobs or the dummy machines. So this was a step we introduced in our previous lecture while solving an unbalanced assignment model. And after introduction of this dummy jobs or dummy machines, the rest of the steps, students, again remain same. And again, we follow the different steps of Hungarian method to solve these problems. That is, first of all, we find out the minimum number out of each row and subtract that particular number from the respective row. And then we find out the minimum number out of all the columns and subtract that minimum number from all the respective columns. Thereafter, we make the different assignments starting from the first rows. That is, if there is a single row, we assign it, and we cross all the other zeros in the respective columns. Similarly, we check down all the rows and all the columns. If there are more than one zero for a row or column, initially we leave it. So after this particular step, if the optimal solution is not obtained, we move to the next step, and we use that ticking method. And again, after ticking method, we draw the different lines, and after drawing the lines, we'll have to find out the minimum number out of those numbers through which lines are not being passed, and then we subtract that minimum number out of these particular numbers and add that minimum number at the points of intersection of the horizontal and vertical lines, and the rest of the values in the previous matrix remain same. Now after doing all of these steps, we got another table, and again we repeat our step number 3, So this process is being continued until we have some optimal solution for our assignment models. So class, this was what we discussed in our previous lecture. Let's have the outline what we will discuss in our today's lecture. We will discuss that what is forecasting and what is the importance of forecasting for the operations manager as well as for all the other managers in the organizations. Then we will discuss the different time horizons for the forecasting, that whether the forecasting is being made for the short term or for the long term or for some mid-term period. Then we will discuss that what are the different steps involved in this process of forecasting. Then of course we will discuss the different types of forecasting, that may be qualitative forecasting, that may be the quantitative forecasting, and again we will discuss some subtypes of this qualitative forecasting as well as quantitative forecasting. And then we will also discuss in detail some of the important quantitative techniques in forecasting. And among those techniques, the most important techniques are time series forecasting, and the similar type of forecasting is the exponential smoothing. And then we will also discuss two very important concepts, that is correlation and regression. So students will also discuss that how this correlation and regression techniques helps us to make the better forecast for the future. So this is our outline what we discussed in our today's lecture. So forecasting. Students, forecasting is a process to predict the future. It is very important for the operations manager to have the forecast for the future in the different situations. For example, if you are producing some products, then it may be very important for the operations managers as well as for the marketing managers that what is the demand for your product in the near future. So for that particular purpose, you can always be able to forecast the demand of your products in future. So that is the particular purpose for in which this forecasting will help us. Then again, forecasting is the process of predicting the future value of the variable of interest. So the operations manager or the general managers may be interested in any of the variable of their choice. That may be the demand of the product, that may be the supply of your products, that may be the price of the different stocks available in a stock exchange. So that are the different variables of interest in which the operations managers are generally interested to have a sort of forecast. Then again, students, as I said, that forecasting is the basis of all the business decisions in the different areas. So this is a sort of technique which is helpful for all the functional managers, like marketing managers, like quality control managers, like financial managers, operations managers, of course. So this is a technique which can be helpful for all the functional managers in order to have the good forecast for the future. And again, this technique will help us to predict the demand or the supply of your products. Then it will again help the financial manager to predict the future profit as well as the cost of their products. And especially for the financial managers, sometimes it is very important that how the inflation rate is being changed throughout the different years, and of course what can be the inflation rate in future. So this is the purpose in which most of the finance managers may always be interested. And again, finance managers or the operations managers may also be interested in the price of the different stocks and the bonds available in the stock market. So for these particular purposes, this technique of forecasting always help us to predict the respective values in future. Okay, class, there can be the three different types of forecasting. If you are interested to make the forecast for less than 1 year or up to 1 year, this is usually referred as the short range forecast. Similarly, if we want to procure the different goods and services for our organization, or we are interested in the job scheduling or finding out the workforce levels, or we are interested in assigning the different jobs to the different machines or to the different persons, or we are interested in finding out the production levels. So these are the different situations in which we can always apply the short range forecast. The other type of forecast with respect to that time horizon is the medium range forecast, and this type of forecast is being made for the time that is between 1 and 3 years. And of course, the situations like sales and the production planning and budgeting, we are always interested in these types of forecasts, that is medium range forecast. Then there is another type of forecast with respect to the time horizon, that is the long range forecast. If you are interested to have the forecast for more than 3 years, or it has the time span of more than 3 years, then it will be called as long range forecast, especially when we are interested to find out the location of our factory or some facility. And again, when we are doing some research and development and we want to have a forecast for the research and development requirements for our organization, so again, these are the situations in which we can always be interested in these long range forecasts. So students, with respect to the time horizon, we can have these 3 different types of forecasts. Now, what steps are involved in forecasting any variable of interest? There are usually 7 steps involved in the process of forecasting. That is, first of all, we have to define that what is the purpose of forecast. That is, whether we want to forecast the demand of our products, or we want to forecast the price of the stocks in the stock exchange, or whether we want to find out the change expectation in inflation rate, or so these are the situations in which we'll have to define that what is actually the purpose of forecast and why we are making forecasting. Then as a second step, we'll have to define the time horizon of the forecast. That is, whether we are interested in short-term forecast or a medium-term forecast or a long-term forecast. And then after defining the purpose and time horizon of the forecast, we'll have to select the appropriate forecasting technique. We will discuss the different forecasting techniques. Among these different techniques, there may be the qualitative forecasting, that may be called the judgment forecasting, or there may be the quantitative forecasting, in which we are interested in the statistical and mathematical calculations in order to have the certain forecasts. So in third step, we'll have to find out that what is the appropriate forecasting technique which can meet our objectives. Then again in class, after selecting the appropriate technique for forecasting, we'll have to gather the data what we are interested, and then we'll have to analyze the data. Again, we can use the different techniques for the data analysis, and then again after this data analysis, we'll have to make the final forecast, and we'll have to implement this forecast, and again we'll have to monitor this forecasting, that whether this forecasting serves the objective we want to achieve or not. And then we'll have to find out the deviation between the actual achievement and the desired achievement, and again we can take some corrective actions in order to make our future forecasts better. So these are the different steps, students, which are involved in forecasting process. There are different types of forecasting, and broadly speaking, we can say there are 2 different types of forecasting, that is the qualitative forecasting and quantitative forecasting. Now, qualitative forecasting, students, is the type of forecasting in which we are interested in some subjective and personal opinion based on the different inputs and the experience of the different experts. So this is a sort of actually judgment forecasting, in which we are not interested in some numerical calculations or mathematical calculations or some facts and figures, but we are just relying on the personal observations and the experience of the different managers. So this is a type of forecasting which is usually referred as qualitative forecasting. Again, students, in this type of forecasting, no numerical data is involved, and generally no statistical calculation is involved in the qualitative forecasting. And qualitative forecasting, again, because we are not having any sort of facts and figures in order to have a more rational decision, but there may be the situation which is in which more of the information is not available, and we have little data in order to have the statistical or mathematical calculations. So this is the situation in which we can always prefer the qualitative forecasting. Again, class, another approach we use in forecasting is the quantitative forecasting. Again, quantitative forecasting is the type of forecasting in which we use the stable and historical data, And again, we use the different statistical and mathematical calculations in order to draw the conclusions and in order to make the certain decisions. So this is very important type of forecasting. Again, if we compare the qualitative and the quantitative forecasting, then the quantitative forecasting is always preferred over the qualitative forecasting, because whenever we make the forecasting on the basis of the personal experience or the opinion or our observations, then it may or may not be work in future, and there may be the biasnesses in this type of forecasting, that is qualitative forecasting. But quantitative forecasting is always preferred on the basis that we make the different calculations, we collect the different data and facts, and after analyzing that particular data, finally we got a conclusion which may be called as the more rational decision making. And this type of forecasting always involves the different statistical and mathematical calculations, and because we are making decisions or we are making the forecast on the basis of certain facts and figures and on the basis of certain statistical or mathematical analysis, so this type of forecasting always have least biases, because our decisions or the forecasts are actually based on the certain facts and figures. That's why this quantitative forecasting is mostly preferred. But again, students, what type of forecast you should use, that also depends on the situation. If there is a situation in which you don't have any historical data or you don't have any information, then again we cannot use that quantitative forecasting because we will not having any data for analysis and for the calculation purposes. So that will be the situation in which we can always opt for the qualitative forecasting. So while deciding that which type of forecast should be used, that depends on many things, and of course the type of the situation you face is so important. Again, students, in qualitative forecasting we can use the different methods, and one of the method we can use for qualitative forecasting is expert opinion. Again, I told you that in qualitative forecasting we usually depend on the personal judgments and personal opinions of the different persons. In this particular method, that is expert opinion, what we do, we get the opinion of the different experts, their observations, their experience, and after getting those opinions and discussions, we finally have a sort of conclusion, and we finally make a forecast on the basis of that particular judgment. Of course, that is not a normal judgment, but the expert judgment, And again, in this expert opinion, if they are being able to use some statistical models or statistical calculations, again, that may be a blend of qualitative as well as quantitative forecasting. So as a pure qualitative forecasting method, if you use that expert opinion, that will just rely on the personal judgment, experience, observation and opinion of the different experts in the relevant fields. And again, if these opinions or judgments are based on the particular calculations, so you can always refer again to the quantitative forecasting method in that particular case. Students, there are two other very important techniques which we used in qualitative forecasting, and these methods are usually referred as a nominal group technique and Delfy method. There is no much difference between two of these methods. What the difference is, I will just tell you. And first, let's see that what are the different steps involved in these methods. First of all, we'll have an iterative process to reach the consensus. Now, students, in this particular method, what we do, we select the different experts, which may be the different decision makers, experts in their fields. That may include the staff and the employees of the organization, that may be the respondents of the organization. So we select these people, and most importantly the expert people in their fields, in order to have the opinion from them. And especially when we talk about the nominal group technique, what we do, we gather all of these experts and the decision makers, staff and the respondents at a place, and we create a sort of discussion among these entities, and after the discussion, we can have the different solutions, and then that particular solution is being discussed among the different experts, and again there may be the different positive points, there may be the different negative points, a debate is being created, and finally after a lot of discussion and consensus, we may have a sort of solution which is generally being accepted by all the experts there. So if you use this sort of method in order to find a consensus about a particular problem, or in order to have a particular forecast, this method is usually referred as nominal group technique. Delphi method is almost same, but the difference is that in Delphi method we do not have the direct contact among the different entities like decision makers, experts and the respondents. But we do in Delphi method, we send the different questionnaires to different experts in order to obtain the different forecasts. Then after getting the suggestions from the different experts, we summarized their suggestions. Then again we redistribute a new questionnaire on the basis of their suggested opinion, and this process is again continued till we have a general consensus about a particular forecast. So the class, what happens in Delphi method, that in Delphi method usually we do not have the direct contact among the different entities. So this is the way in which the Delphi method is different from the nominal group technique method. Otherwise the technique is almost same. Students, again, as I said, that quantitative forecasting is so important for the operations manager, because in this type of forecasting we generally rely on the certain facts and figures on the basis of certain calculations and mathematical analysis. Always we can have a very good forecast which is unbiased and unchallengeable sometimes, because we are not making that forecast on our personal opinions or the experience or observation, which may or may not be right, but these forecasts are generally being made on the basis of the certain facts and on the basis of certain calculations, and if you follow the calculations in the scientific way, then of course no one can challenge these sort of forecasts. So time series forecasting is a method of quantitative forecasting technique, and this type of forecasting is based on past and historical data values, and other factors are not important. So students, whenever we are interested in time series forecasting, it means we should have some historical data. We should have some past data, so that we can have the calculations and we can have the data analysis on this particular data, and all the other factors are not so important, like personal opinion, experience, judgment and some other variables. We are not interested in that, but we are just interested in the historical data of the variable of interest, and on the basis of this data analysis we can have the forecast. So the time series forecasting assumes that factors influencing the past and present will continue influence in future. So students, what is the assumption behind the time series forecasting is that we assume that what happens in the past, that will also prevail in future, or what trend is being adopted in the past, that trend will also be repeated in the near future. So that is the basic assumption behind this time series forecasting. There are different types of time series forecasting, or we can say that different components of time series forecasting in which we are interested. The first type of forecasting is the trend analysis, that is the long-term upward and downward movement in data. So whenever we are interested in trend analysis, it means we are interested in some long-term forecasting, and usually the movement of data is also long-term, that may be in one direction or that may be in the other direction, and in that particular type of forecasting we generally count several year changes due to the population, culture, age. Whenever there are the changes in the different demographic variables like population, age, income and any other variable, then you can see that there may be the different trends among the different variables of interest due to these changes in the demographic variables. So in order to forecast for the future, what we do, we generally analyze this particular trend of a particular variable of interest in past, and on the basis of this past analysis we extend it for the future, so that we can find out that what may happen in the future. So this is the important component of that time series forecasting that is usually referred as a trend analysis. The other important component of time series forecasting may be the seasonal forecasting. And seasonal forecasting, students, is the type of short-term regular movement in data due to weather, vacations, and the customers. Now, weather conditions, that may change, and if you are producing the particular products, the sale of your products may vary according to the weather changes. So these type of changes in data or any variable of interest is usually referred to as seasonal changes, and again, as a component, it is very important part of that time series forecasting. There is another component of time series forecasting, that is the cyclical component, and in this type of time series forecast, the different values are being repeated up and down like waves. That is the like wave. There is up, there is down, there is up, there is down. So that trend is being done on repeating basis, and on that basic trend, if we extend that particular trend for the future, and then we can always forecast that what will happen in the future. So class, this type of forecasting involves the repeating up and down wave-like movements in data after the long-term duration due to the business cycle. Now, what can be the changes in the business cycle? Suppose your product is in introduction stage, then again the demand of your product may be different, and again if your product is at the growth stage of that cycle, again the demand of the product will be different. So according to the different business cycle as well as the product cycle, if you are being able to forecast the demand of your products for the future, that may be referred as a cyclical component of this time series forecasting. Then irregular time series forecasting, and it involves unsystematic, short-term and non-repeating fluctuations in data due to the unforeseen events like earthquakes, strikes, major changes in the products. So class, this type of forecasting involves the unsystematic changes in data that are usually short-term and that are generally due to the unforeseen events. Like अगर कोई earthquake हो जाता है, or that may badly affect your production capacity, and similarly the demand of your products may be changed. So this type of change in data is usually referred as irregular component of time series forecasting. And again, this type of change in data is generally due to the unforeseen events or the unexpected events. So students, these are the four important components of the changes in data. I would say that how the changes in data can be analyzed, and you'll have to examine that the data you have about the products or any variable of interest. You'll have to see that what is the different type of changes in that data, whether it is the irregular change, or it is the wave-like change, or it is the seasonal change due to the change in weather, or due to the change in some customer, or due to the change in customs in your country. So we'll have to carefully analyze all of these components of time series. So we'll have to carefully analyze all of these components of time series data. Students, we use another approach in forecasting that is generally referred as Nave Approach, and this type of approach assumes again that demand in the next period is the same as demand in the most recent period. So in this type of forecast, we prefer the most recent value of data, and according to that most recent value or trend in data, we can have the forecast for the future. And for example, if January sales were 68, then your February sales will also be 68. So generally what happens, we are depending on the most recent data for forecasting our future values. Sometimes this is a very quick method to have a sort of forecast, and it may also be cost effective and maybe a very good method as a starting point. Students, the most important method which we usually use in forecasting, and especially by using that quantitative approach of forecasting, that is the moving average method. And this is a method in which we find the average of the series of past actual values of data. So what we do in this particular method, if you want to forecast the demand of your product, what you will do, you will get the historical data of the demand of your products, that what was the demand in the last 5 to 10 years. You will have a sort of list, and again you can systematically find out the averages of these values, which may help you to forecast the demand of your product in future. So this method is usually referred as moving average method. This moving average method is generally used if there is a little or no trend available, and we cannot have the idea that what are the different changes in the data values which are being happening in the past. So in that particular situation, we can always use that moving average method. This method can also be used up for the smoothing. Smoothing means we can always balance the change of trend in our data values in past. So by using that smoothing technique, we can always have an overall impression of the data over the time. So the students, the formula for calculating the moving averages is the summation of demand in the previous n periods divided by the total number of periods. So this is the simple formula which we may use to forecast the demand of our products for the future. Let's take the example of moving averages, that how we can calculate the moving averages for our sales data. Students, suppose we have the data about the sales of our products for 7 different months, that is January, February, March, April, May, June and July, and the actual data of sales in these months is also given. You can see on this table, that is 10 products, 12 products, 13, 16, 19, 23, 26. So this data may be in hundreds or the thousands. So if we want to calculate the 3-month moving averages, what we will do, we will find out the average for the first 3 values. That is, you can see that the first 3 values are 10, 12 and 13. What we will do, we will sum up these values and then we will divide this sum by 3, so that we can have the 3-month moving average. That is the first available 3-month moving average. So this is the first available 3-month moving average. Now, in order to calculate the next moving average, what we will do, we will just skip this first value, that is 10, and we will add the next value, that is 16. Now in this particular case, we will calculate the average of this 12, 13 and 16, and it will become 13 and 2 by 3. Similarly, for the next step, we will omit this 12 and we will add the next number, that is 19, and we will calculate the average of 13, 16 and 19. We will again divide this sum by 3 and we can get the third moving average as 16. So this is the way we can calculate the moving averages. Now again, we can always calculate the odd number moving averages or even number moving averages, like 3-month moving averages, 5-month moving averages, 7th month moving averages, or 2-year, 4-year, 6-year moving averages. In that particular case, we'll have to centralize the data as well. So this was a general idea that how we can use this method of moving averages in order to have the future forecast. So students, if we draw the actual sales and our moving average forecast on this graph, that is actually the graph between the different sales values for the different months, and you can see that there is a similarity in the actual sales data and moving average forecast. So this graph or these moving averages actually may guide us that what will be the sale in future. So if we extend this sort of average for the future, we can always have an idea that what can be the expected sales in future. So this is basically the purpose of this moving average method, that it helps us and guides us to forecast the demand or sales in future. Okay students, we can always use another sub-method of that moving averages, which is generally referred as weighted moving averages. Now this sort of method is used when you are able to analyze a certain trend in data, and for example, you may be interested that older data is usually less important. So students, when you have the data, suppose that is the sales data for the last 10 years, and you can analyze the different trend of data, you may be able to find out that the most recent data is most important for your organization, and the rest of the data is not so important for your organization, as well as not so important for the forecast. So what you do, you can give the particular weightage or more weightage to your current values, and you can give the less weightage to your previous values. Now previously what was happening, we were giving the equal weightages to all of the values, whether it is the most recent value or it is not the most recent value. So by using this method of weighted moving average, what we can do, we can assign the weights to the different data values according to the importance of these values. So weights can be assigned on the basis of the experience and your own intuition, and the formula for this weighted moving average will be equal to the summation of the product of the different weights assigned as well as the demand, if we are interested to forecast the demand, divided by the total number of weights. So this is the formula for calculating the weighted moving averages. Let's discuss another example that how we can use that weighted moving average. Now suppose students, again, if you have the data for the sales of your product for the different months, suppose, and this is the data you can see in this particular column. Now what you want to do now, you want to calculate the moving averages. Now after analyzing the particular trend in the data, you decided that the most recent data is most important, and you decided to give the weightage of 3 to the most recent data. In this particular case, that may be the last month data. So if you want to give the weightage of last month data more, so you can always give the weightage of 3. Again, the 2 months ago data may be given the weightage of 2, and 3 months ago data may be given the weightage of 1. Now what actually we are doing, we are giving 3 times importance to our data, which is for the last month. Again, we are giving the twice importance to the data, which is 2 months before. So this is a way you can find out the importance of the relevant data, and accordingly you can assign the relevant weights to these data values. So you can see, if we assign these particular weights, that is 3, 2 and 1, the total sum of weights for these values will be 6. So how we can calculate the weighted moving average now? Now students, for calculating the 3-month weighted moving average by using the above mentioned weights, as you can see that the last month data is given the weightage of 3. So what you will do, this is the last month data available. If you are interested in these 3 values, so what we'll do, we will multiply 13 by 3 plus 2 months data, 2 months ago data is given the weightage of 2. So we will multiply this 2 months ago data, that is 12 multiplied by 2 plus 10 multiplied by 1. and we will divide it by the, and we will divide this sum by the sum of these weights, that is 6. So we will get the 3-month weighted moving average, which is equal to 12 and 1 by 6. So this is the 3-month weighted moving average. Similarly, if we want to calculate the next 3-month weighted moving average, so what we will do, we will skip again this first data, that is 10. We will include the next available data, that is for the month of May, that is 19. So we will include the next month's data, that is the month of April, that is 16. So what we will do, again we will multiply 16, that is the last month's data, 16 by 3 plus 13 multiplied by 2, where 13 now is the 2 months ago data, plus then 12 multiplied by 1, which is the 3 months ago data. So after getting this sum, what we will do again, we will divide this sum by 6, that is the sum of the different weights. So we can get the value equal to 14 and 1 by 3. So this is the way, students, we can calculate the weighted moving averages. Again, let me repeat this particular method, that whenever we are interested to assign the different weights to the different values of data, and weights here mean the importance. Whenever we want to give the importance, more importance to a certain data value set, then we will assign the different weights accordingly to this particular data sets. And again, we can use this formula of weighted moving averages in order to calculate the better forecast by applying the certain weightages. So this is the method which is used for the forecasting. Students, another form of weighted moving averages is exponential smoothing, and in exponential smoothing we assume that the weights decline exponentially, and in this particular method, students, again what we do, we again give the more weightage to the most recent data, and there is a formula again for calculating the exponential smoothing. And in this exponential smoothing, we'll have to assign a value of constant, which is usually referred as smoothing constant. Now smoothing constant is generally referred as alpha, and the value of the alpha varies from 0 to 1. And again, the value of the alpha will be decided by the operations managers or the general managers according to their own judgment. That is actually the subjective judgment. And again, we can have the idea that how we should decide the value of alpha. Now again, this value of alpha will be decided on the basis of personal opinion or the personal judgment of the different operations managers. And the method of exponential smoothing is used when we don't have much of the record for our past data. So this exponential smoothing involves little record keeping of past data. In that particular situation, we can always use this method of exponential smoothing, which is also a form of exponential smoothing. Now students, this is the formula for exponential smoothing. That is, our new forecast will be equal to our last period's forecast plus alpha multiplied by last period's actual demand minus last period's forecast. And if we use the different abbreviations to abbreviate these particular statements, we can have that ft is equal to ft minus 1 plus alpha within brackets a t minus 1 minus f t minus 1, where ft is equal to the new forecast, ft minus 1 is equal to the previous forecast, a t minus 1 is equal to the last period actual demand, and alpha is equal to the smoothing constant. And again, we can also refer this alpha to the weighting. We have just discussed about the weighted moving averages, that is, the weights are to be assigned according to the importance of the certain data value sets. The same is the concept of alpha, and the value of the alpha lies in between 0 and 1. And again, higher the value of alpha, higher the weightage given to the recent observation. So the value of alpha actually refers to the particular weightage you are giving to the most recent data. So if you want to give more importance or more weightage to the most recent data, again you can assign the higher value to that alpha that is more close to 1. And again, if you want to assign less weightage to the most recent data, again you can move away from 1, and the value of alpha may be nearer to 0. So this is the concept of this smoothing constant. Again, students, let's have an example that if the predicted demand for your product is 142 and your actual demand for some past period is 153, smoothing constant, suppose that is being decided by the manager as 0.20. So if we put these values in that particular formula, we can have our new forecast, that is the future forecast, as 144.2 or 144. So in this way we can calculate the new forecast for our data values. Students, again we have talked about the moving averages, we talked about the weighted moving averages, we also talked about the smoothing method in time series, that is actually the exponential smoothing. And again, these three methods are very important techniques in order to forecast certain values for the future. And again, the importance of these methods is that we want to have the forecast on the basis of certain calculations. So that's why these are generally referred as quantitative forecast. The other important quantitative forecasting method we can use, that refers to the correlation and regression. Again, correlation and regression are very important concepts in statistics which can always help us for better forecasting. What is correlation? Students, you must have read about the correlation in your statistics and other subjects. That correlation is actually the strength of relationship between the two variables, and it finds out the strength of interrelationship between the two variables. So this interrelationship sometimes is so important for the decision making, that after calculating this correlation between two different variables, you can always take very important decisions. So correlation actually helps us to find out that how strong is the linear relationship between the variables. Correlation does not necessarily imply causality. So students, this is very important. Correlation doesn't always mean cause and effect relationship between the two variables, but that just represents the strength of relationship between the two variables. There are two very important concepts again, correlation and regression. In regression, we are actually interested in the cause and effect relationship, but in correlation, we are interested in the strength of relationship between the two different variables. We generally calculate the correlation by using a formula, and we refer the numerical value of the correlation as coefficient of correlation, and that is generally represented by small r. And again, the small r measures the degree of association or the degree of relationship between the two variables. Again, students, this value of r is so important for our forecasting and the decision making. The value of r lies in between -1 and +1. So students, the value of r lies between -1 and +1. Now -1 means there is a perfectly negative relationship between the two variables. It means that if one of the variable increases, the other variable will 100% decrease. Similarly, +1 indicates the perfectly positive relationship, which means that if one of the variable increases, the other variable will also increases in the same direction 100%. So this is meant by the value of r as -1 and 1. Again, whenever we are interested in calculating the correlation coefficient, there are certain important things in which we are interested. First of all, we are interested in the sign of the correlation, whether there is a positive correlation or there is a negative correlation. If there is a positive correlation, it gives you the idea that both of your variables or both of the variables of your interest are moving in the same direction. Similarly, if the sign of the correlation, that is small r, is negative, it means both of the variables are moving in the opposite direction. That is, if one of the variable increases, the other variable will decrease. If the other variable increases, the other variable will decrease. So there is an opposite relationship between the two variables that is generally represented by the negative sign. If small r is equal to 0, it means there is no relationship between the two variables, and it means that the change, whether it is the increase or the decrease in one of the variable, that will not make any effect on the other variable, and the value of the other variable will remain same. In that particular case, if we calculate the value of r, that will be equal to 0. Another important thing, students, we are interested in this correlation coefficient, that is the strength of r. And again, if the r value is closer to 1, whether it is the positive one or negative one, we can say that there is a strong relationship between the variables. Again, if it is closer to 0, it means that there is a weak relationship between the variables. And if the r value is between 0.4, 0.5 and 0.6, it means there is a mediocre sort of relationship between the two variables. So this interpretation of this correlation coefficient is so important. Students, this is the simplest formula we can use for calculating the correlation coefficient. And again, there are two variables in this particular formula, that is x and y, and if we have the particular data about this x and y, we can always put these values in this particular formula to calculate the value of r, that is the correlation coefficient. Now let's discuss, students, how this value of r helps us in better forecasting or in decision making sometimes. Now let's suppose in this particular case, let's suppose that x is your advertisement, that may be the advertisement expense, that it may be the 2 million, 3 million, 4 million, that is the data for your different periods. And suppose y is your sales, and again you can have the data that if you are spending 2 million on advertisement, you may have the sale of 10 million. Then again, in case you spend 3 million on your advertisement expense, your sale may be boosted up to 14 million. Now suppose this is some hypothetical data, and if we calculate the different values like xy, x square, y square, and we can have the different summation for all of these values, which you can always calculate. And if you put all of these values in this particular formula, again you can get the value of r. Now suppose I am taking this value as hypothetically, again suppose r is equal to 0.7. now what it shows? It shows that there is a strong relationship between advertisement and sales. If you do advertisement expense, it will increase your sales level. So it means you will put all of your resources in order to advertise more, so that may have the good impact on your sales. So that is the interpretation of this value of r. Now suppose if your r value is 0.2, you can see still that is positive but weak relationship. And now you should be very careful that what advertisement expense you should have for your products, because of this weak relationship. And blindly again you cannot use your advertisement expenses. Now sometimes again, if the value of r for this particular data, if it becomes as minus 0.15 suppose, so again this shows that there is an inverse relationship between the advertisement and sale. There is something wrong with your advertisement plan, or there is something wrong with your marketing plan, and you will have to redesign this marketing plan because of this negative relationship. So this is the way we can interpret the different values of R in order to forecast for the future and in order to take the certain decisions in future. So important is this correlation coefficient value. Then again, students, as I discussed that there are different types of correlation coefficients. As you can see in this particular graph, in this graph, if R is equal to +1, it means we'll have this sort of graph. That is, if we draw the values of X and Y in this particular graph, and if we go this particular line, it means the value of correlation coefficient is +1. That is the perfect positive correlation. And what it shows जितनी आपकी x की वैल्यू बढ़ेगी उसी हिसाब से और उसी डायरेक्शन में आपकी दूसरे वेरिएबल y की भी वैल्यू बढ़ेगी. So it shows there is a positive relationship, perfectly positive relationship between the two variables. Now again, students, if we see this particular graph, you can see we have a straight line. It means by adding or by increasing or decreasing any one value, that is the variable x, the value of the y will not change because that is a straight line. So that is the example of no correlation. It means the change in the value of one of the variable will not have any effect on the other variable values. Similarly, this is the example of negative correlation coefficient, that is the perfectly negative correlation coefficient. It is meant that if we have the perfect negative correlation between the two variables, then it means that if one variable moves in one of the direction, the other variable move in the opposite direction and with the similar strength. So that is meant by the perfect negative correlation, that there is perfectly negative relationship between the two variables. And again, as I told you, that the positive correlation generally lies between 0 and 1. But when we overall talk about the correlation coefficient, it can also be negative. So the general value of the correlation coefficient may lie between -1 and +1. Okay, students, there is another concept we generally use in statistics as well, that is the coefficient of determination. And coefficient of determination is actually the square of the correlation coefficient. अगर हम correlation coefficient की value को square कर देंगे तो आपका correlation या coefficient of determination बन जाता है. And it measures the percent of change in y predicted by the change in x. So what is the interpretation of that coefficient of determination? It means that it will measure the percentage change in y predicted by the change in x. कि आपके जो डिपेंडेंट वेरिएबल में चेंज आ रही है वो कितने % आपके इंडिपेंडेंट वेरिएबल की वजह से आ रहा है. दिस इज जनरली बीइंग इंटरप्रेटेड बाय द कोएफिशिएंट ऑफ डिटरमिनेशन, दैट इज r square. Now if r is equal to 0.901, as you can see in this particular case, now it means that there is a very positive strong correlation between the two variables. And again, if we calculate the coefficient of determination r square, it will equal to 0.81. It means कि डिपेंडेंट वेरिएबल में जो आपकी चेंज आ रही है या y में जो चेंज आ रहा है वो 81% जो है इस वेरिएबल x की वजह से आ रहा है. तो दिस इज द इंटरप्रिटेशन ऑफ दिस कोएफिशिएंट ऑफ डिटरमिनेशन. Students, there is another method we generally use for forecasting, and that is generally referred as associative forecasting. Again, in this type of forecasting, we are interested in the association, but most importantly, we are interested in the cause and effect relationship between the two variables. So, by fitting a trend line to the historical data points to project into the medium to long range forecast, so by fitting a trend line to the historical data points, we can have a projection for the medium to the long range forecast. Linear trends can be found using the least squares technique. You may have learned about that regression line or the simple regression line, and that is generally written as y is equal to a plus bx. Here in this particular equation, y is the dependent variable and x is the independent variable. A and b are the different constants, and generally we say a as the y-axis because this value of a intersects the y-axis at a particular point, and b is known as the slope of the regression line. Now students, again let's have a difference between correlation and regression. Correlation just find out the relationship between the two variables and not the cause and effect relationship between the two variables. But this particular concept, that is the regression concept or the least squares technique, it actually helps us to find out the cause and effect relationship between the two variables, that what causes what. Another difference is that in case of correlation there is no dependent and independent variable. If we change and interchange the values of x and y, the value of correlation will not change, that will remain the same. But in this particular case, that is the regression or least squares technique, if we interchange the two variables, that is x को अगर y बना दें, y को x बना दें, तो आपकी पूरी equation जो है वो change हो जाती है. So it means that in correlation there is no dependent and independent variable, and we are not interested in cause and effect relationship. But in regression line and in this least squares technique, there would be a dependent variable, there would be an independent variable, and actually we are interested in cause and effect relationship between the two variables. So students, this least squares method actually helps us to find out the deviations between the different observed values and the actual values. So again, actually we are interested to find out the trend for our forecasted values, and again we can find out this particular trend by using that least squares method. We can always use that normal equation method you may have learned in statistics subject, but for the sake of simplicity we can always use these formulas for calculating the values of B and A. But for the sake of simplicity, sometimes we can always use this formula for B and A. Actually, whenever we are interested to find out the regression equation between the two variables, actually we are interested to find out the values of A and B, which are the two constants. So if we can directly use this formula for the calculation of B and A, we can easily have this regression equation. So formula is B is equal to summation xy minus n x bar y bar divided by summation x square minus n x bar square. And again we can find out the value of A is equal to y bar minus bx bar. So if we get the values of x and y, we can always have the different calculations in order to put those calculations in this formula to calculate the values of A and B. Now suppose students, this is a problem that we suppose have the data for the different time periods. Suppose students, for these different years, that is 2001 onward up to 2007, the demand of electricity is 74 megawatt, 79, 80, 90. So these are the different values. We can always represent these different years as 1, 2, 3, 4, 5 and 6, 7 by taking all of these values in the form of that independent variable. So whenever we have the data in the form of these years, we can always take the values of these time periods as 1, 2, 3 and onward. So this is now our variable x and this is now our variable y. Now we can easily calculate the x square, that is by scaling this particular data. Then again we can calculate xy by multiplying the values of x and y. Now again, by getting these sort of sums, if we calculate these values in our formula, we can get the values of B and A. Now in this particular case, the value of B is equal to 10.54 and the value of A is equal to 56.7, and if we put these particular values of A and B, we can get this equation, that is y is equal to 56.7 plus 10.54x. Now students, we got this trend line actually. Now this trend line interpretation, now this trend line's interpretation is so important. Now what is meant by this particular value, which is actually B? It means that if we increase the value of independent variable by 1 unit, the value of dependent variable will be increased by 10.54 units. Now this is a very important interpretation. That is, every time when we will increase the years, because x are representing the time periods, that is the different years, every year your electricity demand will be increased by 10 times. So this is very important interpretation, and you are being able to forecast or you are being able to have the idea that what would be the demand in the future. So this B interpretation is really important in this particular case. Now students, again, if you refer to the original table, we have represented the time period value 2007 as 7. So now if you want to calculate the demand for 2008, what you will do, you will just put the value of x is equal to 8 in this particular equation. If you put x is equal to 8, you can easily get the value of demand for 2008. Similarly, by putting the value of x is equal to 2 in this particular equation, you can get the forecasted demand for the year 2009. And similarly, you can always forecast the demand for the next 10 years. So this is a way this trend line and this regression line helps us to forecast the future values. Students, we just discussed the simple regression line in which there was a one independent variable, there was a one dependent variable, and our least case line was y is equal to a plus bx. But actually in reality that doesn't happens. There are so many variables which actually depends the values of our dependent variable. So actually there may be more than one independent variables. So our multiple regression analysis is the sort of analysis in which so the multiple regression analysis is a sort of regression analysis in which there may be more than one independent variables, and our equation may be like that, y is equal to a plus b1x1 plus b2x2 plus b3x3 and so onward. So this type of regression analysis is generally referred as multiple regression analysis. So again students, as we compute the value of that simple regression equation, we can always compute the values of these constants, that is a, b1 and b2, by using the different formulas, and accordingly we can have the different interpretations, and we can always forecast the value of this dependent variable in future. So this is again a very important concept, that how we can use that correlation and regression concepts for our future forecasts. So students, in our today's lecture we discussed some important concepts, that is the forecasting concepts, that how we can have the forecast for the future, and we discussed about the different steps in the forecasting. Then we discussed about the different types of forecasting, that may be the qualitative or the quantitative forecasting. Then we discussed some important types of qualitative forecasting, like expert opinion, like nominal group technique and Delfy technique. Then most importantly, we discussed some important methods of quantitative forecasting, and the most important methods we discussed is the time series method, and again we can use the weighted time series. Then again we can use the weighted moving average method or exponential smoothing method. And again in the end we discussed about the correlation and regression concepts, that how we can make the important decisions and how we can have the important forecasts for our future. So students, this is the end of our today's lecture, and I wish you make the practice of all of these concepts, and this is all for our today's lecture. Wish you best of luck. Khuda Hafiz.